All right, domain of rational expressions and multiplying and dividing rational expressions. Okay. So, first of all, we want to start what we mean by rational function or rational expression. Rational expression, the word ratio is a part of that. And so this is just a ratio of polynomials. So that, of course, requires that we know what a polynomial is in the first place. If we write f of x equals 2 in front of that, then we're talking about a rational function. Okay, so our things, for example, like, well, you can see some later on this page, but even something like 1 over x minus 3 would be a rational expression. If we say that's equal to y, then now we have a rational function that we're talking about there. So ratio of polynomials, there's not going to be any square roots, there's not going to be any e to the x, no logarithm, no sines, no cosines, no tangents, none of that stuff involved in here. Okay. So the domain of a rational function. When we're concerned about domain, we always assume that the domain is all real numbers unless we have some reason to exclude them. This is completely out of context right now, so there's no story that would exclude any of these values. But as we look at this, we see the potential for division by 0. There are no logarithms, so we don't have that restriction. There are no even roots. We don't have that restriction in here. So the concern when it comes to the domain lies solely in the denominator and the question of, are there numbers such that 3x squared minus 4x minus 15 might equal 0? And if there are values, then we need to get rid of those values. So the way we would find if there are is to try to factor this. Fairly small box here, but we'll go for it. 3x squared and a minus 15. We go up to the side here, 3 times negative 15. We multiply the 3 and the negative 15. We're looking for two numbers that multiply together to give us negative 45, but add together to give us negative 4. Okay, so 45 can be 15 and 3. Those are too far apart. They could be 9 and 5. 9 and 5 are 4 apart. So let's go with a negative 9 and a positive 5. And those are going to go into our boxes here in either order. Greatest common factor on this top here would be a 3x. And if that's a 3x, then that has to be an x. This would have to be a minus 3. This would have to be a plus 5. The 5 and the minus 3 make a negative 15. So this denominator could be factored as a 3x plus 5 times an x minus 3. We want to know what numbers make that 0. Well, that'll be 0 if 3x plus 5 is 0, or if x minus 3 is 0. This would happen when 3x is negative 5 and x is negative 5/3, or when x is 3. Those numbers we have to take out of the domain. So as an interval, we could write the domain of this function as all the numbers from negative infinity to negative 5/3. Pick up again on the other side of negative 5/3 and go to 3, and then pick up again on the other side of 3 and go to infinity. So we could define the domain of that. Okay. Or we could just say that the domain is x is not equal to negative 3/5 or negative 5/3. Or 3. So I could write it that way as well. You have to know what numbers we're not allowed to use. Okay? Remember, restricting those just means that if you try to input either of those numbers, there is no output that goes along with it. Okay, so simplifying rational expressions. Finding that that domain is always an important part, so we're going to be looking at factoring a lot. If it's like this, sometimes it will already be factored for us, but let's go ahead and factor x squared plus 8x plus 12. We know we want 1 times 12 is 12, and we want it to add up to be an 8. And 6 times 2 makes a 12, and 6 plus 2 is an 8. So if we put a 6x and a 2x there, that's an x and an x. That would be a plus 2. This would be a plus 6. So we could write this as x plus 2 and x plus 6. And right away we can make note of the fact that the domain of this problem is that x cannot equal -2 or -6. All right, but this asks us to simplify this much as we would simplify a fraction. If there's a greatest common factor in the numerator and the denominator, then we cancel those out. So let's factor the x squared minus 2x minus 8. So we got the x squared and the minus 8. 1 times -8 is a -8. We need to add to -2 a -4 and a positive 2 would do that. So minus 4x plus 2x, xx, that'd have to be a minus 4 and a plus 2. So this is x minus 4 and x plus 2. And we see that there is a common factor of x plus 2 in the numerator and the denominator, so this simplifies to x minus 4 over x plus 6. And we still need to continue to make note of the domain. In the simplified version here, the -2 would not cause a problem, the -6 still would, but because the original problem had a problem with -2, we have to continue to include in the domain that -2 as an input will have no output. All right, multiplying rational expressions. We already reviewed when we multiply fractions, it's just numerators times numerators, denominators times denominators, and then reduce if we can. So most of this is already factored for me except for this part, so let's go ahead and factor that. An x squared and a 4, 1 times 4 is 4, they need to add it together to give me a 5, that's a 4 and a 1. So this would be a plus 4 and a plus a 1. So if we string the stuff across the top, we've got the 2x plus 3, we have an x plus 4, we have an x plus 1, all in the numerator. In the denominator, we have an x plus 2 and an x plus 4 and an x minus 3 squared. We can see from this that the domain, numbers that we're not going to be able to have are a -2, a -4, or a 3. So those are the 3 numbers that will not have an output if I use them as an input. But from a simplification standpoint, I have an x plus 4 there, and I have an x plus 4 there. So this is equal to 2x plus 3 times x plus 1 over x plus 2 times x minus 3 squared. Now, you could multiply all those together again and obscure what the factors are and things like that, but the reality is this is going to be the useful version of this anyway. So I'm not going to multiply these things back together. I don't know what it is that they want me to do with this, but I'm pretty sure that whatever it is, I'm probably going to want it to be in this factored form. There are some exceptions to that, but most of the time that's going to be what we're looking for. And again, you don't see the x plus 4 in the denominator anymore, but it was there originally, and so it can't be a part of that domain. All right, dividing rational expressions. So we got a fraction divided by a fraction here. We have, we rewrite that first of all as the 2x plus 5 times the x plus 7 over whatever. We're going to go ahead and factor this. We'll go ahead and just write it as it is right now. X squared minus 2x plus 1. Divided by, we rewrite that as multiplication by the reciprocal. And so when we flip that one over, we get an x plus 2 here and an x plus 7. And we've got an x squared plus x minus 2 there. Okay. So let me go ahead and factor these different parts. So we got the x squared and the plus 1. X times 1 is 1, and these need to add up to a negative 2. So that sounds like a negative 1 and a negative 1. And negative 1 times 1, that all checks out. So this part is equivalent to x minus 1 times x minus 1. And we'll factor the blue one. X squared there and a minus 2. 1 times negative 2 is negative 2, and they're supposed to add up to a positive 1. Sounds like a positive 2 and a negative 1. And so this is equivalent to x minus 1 times x plus 7. So, looking at what we've got here, we can see domain. Again, we can make the call on the domain, everything that is or was in the denominator. Okay. So, at one point, this x squared plus x minus 2, which factored here, was in the denominator. So, my x cannot be equal to 1. Or negative 7, or anything that's in the denominator now, which includes a 1, a negative 7, and also a negative 2. So those are the values that I can't have, because there's multiple divisions that are going on here. But now let's take a look at simplifying that we can do. One of these x minus 1s can cancel with that x minus 1. They'll equal 1 when we divide them. I've got an x plus 7 here and an x plus 7 there. Those can go, and so what I'm left with in the numerator is just a 2x plus 5 and an x plus 7. And in the denominator, I'm left with an x minus 1 and an x plus 2. So that is finding the domain, that is what a rational function, rational expression is, multiplying them and dividing them.